This class is packed with curious and inquisitive students. And in this session on algebra, you're all going to explode. What are we going to learn now? Well, it is approach in problem solving. So get ready to participate and see how do we find solutions to problems. We'll begin with simple questions and solve the same question in four different ways. You need to suggest as we move along what could be these four ways. Are you there with me? Yeah. So, what we saw earlier was how do we find patterns and rules? For example, when we took triangles and made a pattern of combining triangles to form bigger triangles, what did we notice? We saw that in the first pattern, there was only one triangle. And then when we increased, they became four with two layers of triangles as shown in this figure. And in the third pattern, it became 9. So these are the pattern numbers which are 1, 2, and 3. And what did we notice? The number of triangles were square of the pattern number. 1 square is 1, 2 square is 4, 3 square is 9. So from the observations, we could see the pattern and figure out if we continue in this fashion, if we want to find the number of triangles in the 10th pattern, it should be what? It should be 10 square, which is equal to 100. And therefore, we had a simple rule. Rule was that if it is any pattern number, let us say n, in that case, the number of triangles will be n squared. You see that. So that was the rule which we called explicit pattern rule. Now, explicit pattern rule, as you all realize now, helps us to quickly get to the solution. Why? Because we have a formula in hand, and in that formula, there is a variable. Now, this variable can have any value, and that value helps us to solve real life situations, right? That is what we saw in the previous session. Now, we are further going to explore the usage of this formula, but well, the first case is to find the formula itself. Correct? So we'll take up some questions which we are saying problem solving questions. And while doing so, we are going to achieve something which will be called a rule to solve that problem. General name, of course, is the formula. Correct? So I think you got the gist of it. So now let your neurons be excited and let us now explore. How do we find solutions to problems in different ways? Let's take up a very simple case. I'll take a rectangle, right? You all know what a rectangle is. Rectangle has two sides, length and width, right? And right angles. The perimeter of the rectangle is sum of all the sides, and the area is product of length and width. Most of the time, we know what the length is and what the width is. In that case, we can easily find both perimeter and the area. Well, if the length is 4 centimeters and width is 2 centimeters, in that case, what is the area? Area will be product of these two numbers, that is 4 times 2, which gives us 8. The units become centimeters square. And how about the perimeter? Well, the perimeter will be sum of all the sides. The sides are 4, 2. This is also going to be 4, and that is going to be 2. So 4 plus 2 plus 4 plus 2. Well, there are two 4's and two 2's. We can also write like this: 4 plus 2 both come twice, right? So if we consider these two sides, they're repeated twice outside. So we kind of simplified our expression as you learned earlier in order of operations, correct? So it's kind of a reverse distributive property. Okay. Now, 4 plus 2 is 6, 6 times 2 is 12, and we know this is 12 centimeters. Well, some of you will directly count 4 plus 2 plus 4 plus 2, which is 12 centimeters. Good enough. So we found both area and perimeter of this particular rectangle. Simple, since the length and width were given to us. Now, there could be many situations, real life situations, where, let's say, we have a garden and we want to make a garden with area of 20 meters square. What should be the length and width? Now, that is the real life situation. That is to say that we know the area, we don't know the dimensions, what are length and width. Well, sometimes it could be that we have some limited fence and we'll say, well, let us fence a portion of our garden. And we know the length of the fence which will be put to form a rectangular safe area in the garden. Now, if we know that the length of the fence which we have is 30 meters, what could be the maximum area which can be enclosed in this 30 centimeters of fence? So, by using 30 centimeters of fence, what could be the maximum area enclosed? Again, we really know the perimeter because that fence is going to come on the boundary of that rectangular area. But we need to find what length and width could be. I hope you find it interesting, right? Suggest. How can we find length and width if we know area and perimeter also? Well, that is interesting. And that is what we are going to explore. But we'll take some small steps to reach there. Okay, so first thing first, since we don't know what the length and width could be, we'll assign variables to both these things, correct? And therefore, we'll say let the length be L and the width be W. In that case, area will be their product, length times width, right? And the perimeter will be twice the sum of length and width. And so we have a rule which we are going to call as a formula for us, right? So we have a formula for area which is product of length and width, and we have formula for perimeter which is twice sum of length and width, right? Now these are called expressions. Now the two expressions which we wrote here, length plus width, and then rewrote as 2 times length plus width, they are also called equivalent expressions. They convey the same meaning, their results are always same, they are equivalent. Correct? Now what you notice here is in our first example, we got a fixed value. And here we do not have a value, we have a general formula. Do you see that connection between arithmetic and algebra? Well, in algebra, we had been talking about variables which could take any value, but their value is not known. Since their value is not known, we cannot really evaluate the answer as we could do earlier, which was the arithmetic part which we had been doing so far. Now, in algebra, we derive formulae, and based on the given values, we can now calculate the answer. Correct? So that is going to be the algebraic approach. So I hope that is absolutely Clear, right? So let me summarize here about what we learned about the variable, correct? And what do we notice here? So we notice that length and width are unknown numbers whose value can vary, and they are called variables, right? General formula derived using variables provides flexibility in real life problem solving applications. The flexibility here is that if I know that area is 20, I could assume length to be 4, width to be 5, for example, right? Well, I could also say, well, width could be 2, length could be 10. Product of two numbers is 20. That's the whole idea. So we have a lot of options, infinite solutions for the same question. But well, if we also know the perimeter is fixed, then we have a particular answer, a particular value, the dimension of the rectangle. Exactly. You got the idea. So when we have number of conditions to work with, we can actually find the solution to that particular question. Correct? So the idea is when we have a problem, break it down into smaller pieces which will give us expressions, and those expressions can help to resolve the situation. Perfect. That is what we do in algebra. So, algebra is the branch of mathematics that deals with variables, numbers, and various operations on them. Clear? Let's take up a concrete example to evaluate and find out what length and width could be. Perfect. Here is an example for you. I'd like one of you to read this. Okay. It is based on problem solving techniques which we are going to explore. And in this particular example itself, we will see four different ways of answering this. Right. The question here is find area of rectangle with perimeter of 18 meters if its length is twice the width. So we are given two conditions in this particular situation. We need to find area of a rectangle with perimeter of 18 meters. So we are given perimeter which is 18 meters, and we are also given a condition if its length is twice the width. So if I say L is the length, then it is twice width. Correct. So we are given two conditions. From these two conditions, what do we need to find? We need to find what is the area. Do you see that? Well, to find area, we have to multiply length with width. But what is width? That is also not known to us. So that is how our creative minds start working as soon as we read a question. Perfect. So when you read the first statement, which is find area of rectangle, so find area of rectangle, we need to find A. With perimeter of 18 meters, we are given perimeter. So this is what we need to find, and that is what which is given. Do you see that? We are given perimeter of 18 and its length is twice the width. We are also given that the length L is twice the width W. Correct? Sketching always helps, so we'll also sketch a rectangle, write down the variables associated with length and width. Right. So that is always the first step. So first step is when you read a question, list out what is given to us, what we need to find out, and make a small sketch on the side with all the given information. Perfect. So that is what we have. Right. Now, let us see how do we solve this question. We have different approaches. The very first one, I'm calling this strategy as arithmetic approach. Now, when I say arithmetic approach, I really mean that we'll not derive any formula, but we'll work with some numbers, numbers for length, numbers for width, knowing that the relation length equals to twice width is given to us. And for that condition, we can find the perimeter. You get the idea. Perfect. So we'll make like a T chart, a table, as we did for finding the pattern rules. Correct. So let's make a table where, where we'll define width and the length. We also know that length is twice the width. And let's take some numbers for width and double them up to write the numbers for length and multiply them to get area. Okay, but we are given the perimeter. Okay, so perimeter is what? Perimeter is sum of length and width times 2. So the third column in this case should be perimeter. So we'll make three columns. And what do we need to find out? Keep that in mind. We need to find out that the perimeter should be 18. So we need a combination of length and width which could give us perimeter of 18. So that is our first step. Correct. So let's take width of 1. Then length is twice. It could be 2 only. Perfect. Right. So it is 2 times 2. And the perimeter will be 1 plus 2 is 3. 3 times 2 is 6. But what are we looking for? We are looking for perimeter of 18. That doesn't suffice. Okay. Let's take the width of 2 now. When you double this up, you get 4. And the perimeter, when calculated, 4 plus 2 is 6. 6 times 2 is 12, which is lesser than 18. Then we'll try the width of 3. Double it up to 6. 6 plus 3 is 9. And twice it is 18. And that's what we want. We now know what could be the possible dimension for this particular rectangle. So if the rectangle has a width of 3 and length of 6, in that case, we do get perimeter of 18. So now we have figured what could be the possible length and width to get exactly 18 meters of perimeter. So that should be in meters, 3 meters and 6 meters. Perfect. Since we know that is length is 6 and width is 3, we can now find the area by product of length and width, which is 6 times 3. That gives us the number 18, and the units will be meters square since both are in meters. Correct? So do you see how by estimating some values for width we could find what length should be, and then we checked for the perimeter. We did get the right solution. The numbers which fits in is width of 3, length of 6. That gives us the given perimeter of 18. And therefore, we can now find the area, which is the product of 6 and 3, 18 meters square. So that's an effective approach if we have a simple solution. Well, if I change that number 18 to, let us say, 20, then this becomes slightly tricky, right? Because in that case, if I write 4 for width and double this up, I get 8. Perimeter will be 2 times 4 plus 8. So 12 times 2 is 24. So we have actually missed the number in between. Do you see that? Now that means that you have to try a value here which could be 3.5, correct? And then you will put some value, double this up, 7, and keep on working like this. It could be very tedious, right? If I give you a number which is 19, it'll be even more difficult. You get the idea. So this approach works. However, it is not a very efficient way of working. So let us now adopt our algebraic approach. So that is going to be the second strategy to solve the same question. Correct? Again, we have exactly the same question. We have a rectangle whose length and width are not known to us. However, what are we given here? We are given that the perimeter is 18 and length is twice the width. With this condition, we need to find the area. So that is what is required. Correct. Now we know what area is. Area is product of length and width. That means we need to find what width is. Correct. Well, we can say that since length is twice width, we could actually write area as length times width as instead of L, which is for length, we can say 2 width times width, right? Which is twice width square. So we do have area which could be twice width square. So that is to say, if I find what width is, I know what area is. You get it? So these are the thoughts which come to our mind when we look at a question like this. Correct? Now the question is, how do we figure out the width? Okay, we are given that the perimeter is 18. That is what is given to us. That could help. Yes, it can. Since I can relate perimeter with both length and width. Correct? We know what perimeter is, so we will know in a way what width could be. Perfect. So that's the whole idea. So the strategy actually is thinking about a solution in small steps. Right. Now we got all this. Can you now figure out what could be the area of this rectangle and how do we find it? Well, you guessed it. The solution is right before you. First, let's define variables for the width and the length. So we'll say W for width, L for length. We also know length is twice the width, so we have written that down. And now, what is perimeter? Perimeter is twice sum of length and width. Correct. And we also know that length is twice the width, so we replace length with twice the width. We have now an expression on the left side which is 2 times 3w. We combine these like terms, twice width 2w and w. So when you combine them, you get 3w, and 2 times 3 is 6. 2 times 2 times 3 is 6. Therefore, perimeter is 6 times width. So we can now find what width is. It is perimeter divided by 6. It is the quotient of perimeter P and 6. You get it? So, from the perimeter given to us as 18, we can divide 18 by 6, which gives us 3. And therefore, now we know that the width should be 3. Once we know width is 3, we can find the length, which is twice the width. Multiplying 3 by 2, we do get 6 as our answer. So now length is 6. Since we know what length and width are, just find their product. And that gives us 6 times 3 as 18. So we have area of this particular rectangle as 18 meters square. Clear? Anything interesting you watch here? Well, very interesting that both perimeter and area have the same numerical value 1818. Of course, the units are different, meters for perimeter and meters square for area. However, here is the algebraic approach. How did you find it? Isn't that interesting? You can now see that with this approach, we could actually use any value for perimeter P and get the solution. Correct? Since we have related perimeter with width and we have also related area with width. Correct? So in this particular case, we know width is perimeter by 6. 1/6 of the perimeter will be the width and area will be product of width and length. We know that area is going to be twice square of W, right? So that gives us the answer, or rather a formula, which can help us provide solution to many similar questions where the value of perimeter could be different. It could be 20, it could be 30, it could be 100, it could be 45, or any number, right? We can now solve this question. It becomes a general solution for us. How do you find it? Perfect? You liked it? Great. Let's move on and look into some other way of solving this question. Now, I've introduced you the complicated part. Let's see the fun part of it. How easy it could be. Well, here is a very easy solution. We were given that the length is twice the width. So that is our rectangle with length and width. Since length is twice the width, I could write two W's on the length side, correct? I could write length is twice the width, we know. Okay, so length is twice the width. And therefore, I could write W plus W, that is twice the width. Now, what is the perimeter? Clearly, perimeter is 1, 2, 3, 4, 5, 6 W's. Wow. So we have a perimeter which is 6 times the width. And that gives us the width and perimeter relation within no time. You see that? 1/6 of the perimeter is width. How easy it was, correct? Since we know perimeter is 18 dividing by 6, we again got the same answer. That is, width is W, length is twice width, which means length will be twice 3, which is 6, and the area will be product of these two, 18 meters square. Do you see that? So at times, logic really works. So when we look at a question, we have to see logically what do we get? Well, many times you can at least estimate your solution. Perfect. So many times you could estimate logically. Keep a note of this. So while we are trying to solve a question, we are understanding different strategies. Now, these strategies can be applied at different times, and we will soon tune ourselves to work with the best. You get the idea? Okay, but approaching a problem in different ways in itself is the brilliant idea, which we are going to explore, correct, further. Oh, how further? Okay, one thing could be in this question, what have we seen? At the end, area is related with perimeter, right? Area is also related with perimeter times something, some constant k, right? It could be a 1/6 in this case, correct? But some constant. So area is related with perimeter in some way. How about finding this relation, right? So relate with a formula. So that is going to be the approach, correct? So I'm calling that as our strategy number 4. So what we do is that we provide a general solution. So in this particular case, what we noticed was that area is length into width, correct? Length is twice the width, perfect. So we get an expression twice square of W. Right. And that becomes the area. But we know that in our case, we found that the perimeter is given to us, and 1/6 of the perimeter was W, correct? 1/6 of the perimeter was the width. We have substituted this value of width here, a bit of algebra here now, and once we do that, we can square it. When we square, we get what? We get perimeter square, and 6 square is 36. This can be simplified, and you get the perimeter square over 18, right? So we have a general formula here, correct? So that is what we are saying. Now, in this particular situation, we have a general formula where area could be written as the square of perimeter over 18. Do you see that formula now? Now, if I read the question, find area of a rectangle with perimeter of 18 if its length is twice the width. So this particular question, length twice the width, gave us the relation between perimeter and width. And now, knowing the perimeter, we have the area. You get the idea? So directly we get the area from this particular formula. Correct? Now, you can use this for the given condition anytime. That's the beauty of this solution. You loved it? Perfect. How about approaching in a different way? Well, I think what was the most interesting approach in solving this particular question? Let's have a vote. Which way did you find easier? I get it. The logical method, right? The logical method, splitting length as sum of two W's, finding perimeter. It requires minimum calculation and it does give us a formula to work with. You see, most efficient way we approach logically. Well, many times the questions could be very difficult, so we may have to apply different approaches. Can you think about some other approach or strategy to solve such a question? Well, we could also solve this graphically. Let's explore how. So, this time I have taken this as an exercise for you. We'll explore together. So, we have the same question. We are saying find area of a rectangle with perimeter of 18 meters if its length is twice the width. So, there we have our rectangle whose length is L, width is W. We know that length L is twice the width. And we also know that perimeter is 18. And we need to find the area. And that is, we need to find both length and we need to find width. We know that length is twice the width. That means width is the thing which we need to find. Okay. Now, how can we do this using a graph? Here we have coordinate axis. Let us say on one side of this we will have one parameter which is what? What should I put on the horizontal x-axis? Let's read the question once again. It says find area of a rectangle with perimeter of 18 meters if its length is twice the width. So when I read the statement, length is twice the width, that means the independent variable is width, correct? And length is dependent on width. Length is twice the width. You get the idea, right? So length is twice the width. We know that there is a relation between the two. Okay. We need to now decide about the scale of this particular graph. How do we figure this out? Well, there are a few more things which are known to us, and that is the perimeter of 18. We know perimeter is twice length plus width. We know that. Okay. Now, in this particular case, since it is 18, 18 is twice length plus width. That means length is twice width. So we'll write this as twice width plus width. Correct. So what we have? We have 18 equals to twice 3w as we did earlier, right? So we have 18 equals to 6w, right? And we can find that 18 divided by 6 is width, and that is 3. So we do get solution doing like this, but that is not the idea. Idea is how to get this solution using a graph. Now tell me, how do we get this solution using the graph? Well, we could do one thing. We'll again explore the same thing. We know length plus width is how much? Well, perimeter is 18, so in our case, let's use a different ink. In our case, we know length plus width should be half of 18. So that is 9, correct? So length plus width is 9. Why did we relate length and width? Because see, we are relating length and width. So that means from the given information, you have to relate both your variables. We don't know what the width is. We don't know what the length is. But what we know is their relation. Length is twice the width. So coming back to this, length is twice the width. That's a key. Okay, so we know length plus width is 9. Now when we know length plus width is 9, we can further explore many things, right? What can we do with this? Length plus width is 9. That means what is length equals to? Length is 9 minus width. So from 9, we can take away and find the value of width. That is what it is. And we also know that length is always a positive number. It is greater than 0. Do you see that interesting part? It is greater than 0. That sign is for greater than. And here, if width is 9 or more, then the length becomes negative. So that means that width is what? Well, width is less than 0, is greater than 0, but less than 9. That is what it means, correct? So we have a restriction. Do you see that? So we have a restriction on the width. The width in this particular case, when the perimeter is 18 and the length is twice the width, it has to be between 0 to 9. So we do get a scale value. Do you see that? So width could be between 0 to 9. That is very important to understand. So when we are looking at a graph, we need to make a scale. To make a scale, we should have some idea about what is the value which could be considered. So now we know that width could be between 0 to 9. Okay, so let's make a drawing now. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8, and so on. Till 9 we can make this, right? No problems. Of course. Now we are saying length is twice the width, right? So again, length is twice the width. And looking into our space, what we could do here is we are writing width as in the units 1, 2, 3, 4, 5, 6, 7, 8, and so on. For length, we could make a scale which says twice, right? Why not? So 2, 4, 6, 8, 10. Let it be like this. So we are writing on this side length as 2, 4, 6, 8, well, we know it cannot be 10, but let's write it. Because taking away from 9 means length is less than 9, right? So we know length is greater than 0, of course, And we also see that length is less than 9, correct? Because width could be 0 at the most, so length is 9 take away 0, so it has to be less than 9. Perfect. So we got some restrictions here, right? So this area is very important to understand, and we call this restrictions. It is a very important step in problem solving. So when you look at the question, you should know what could be the valid values for us, right? Anything in between 0 and 9 is valid for us in this particular situation, right? That becomes the domain for our solution also. These are the expected values. Okay. Now from here, we can actually plot the points which will give us the sum as 9. So that is one idea. When we add length and width, we could make two graphs from two different conditions. So one condition given to us is perimeter equals to 18, and that resulted into sum of length and width as 9, correct? Because twice it was. So that is one equation. And the second equation which we are working on is that length is equals to twice W. Correct. So let's plot the points for the two. So one is in green, length is twice W. So we get a point here. If length is 1, if width is 1, length is twice. If width is 2, 4. If width is 3, 6. If width is 4, 8 is the length, right? And 5 is not a value to be taken. Because that will make length as 10, right? So length as 10, but length has to be less than 9, so somewhere in between. So at least we have a set of points here to work with. And this set of points are because of the second relation, which is length is twice the width. Correct? Now let's get back to the first relation, which is length plus width is 9. Length plus width is 9. We got from here. Twice perimeter, twice length plus width is perimeter. So length plus width is half of perimeter, correct, which is written here. So if I take, now let's do this, that the sum of length and width is 9, that really means that if the value of width is 1, and if I make sum as 9, then the length should be how much? Length should be 8, because now we are working on length plus width equals to 9. You see that? So length and width equals to 9. If it is 2, 2 plus 6 is 8, right? 2 plus 6 is 8, so we get a point there, correct? For 3, 3 plus 5. We want 9, sorry. So with 2, 2 plus 7, sorry. For 2, 2 plus 7 is 9. And with 3, 3 plus 6, 3 plus 6 is 9, right? So we do get an overlap. You see that? So we do get overlap, which is if the width is 3, then 3 plus 6 equals to 9. Length has to be 6. And this point coincides with the previous condition, correct? And therefore, we have a solution when both the conditions are true. So the solution here is both conditions true. Do you see that part? So when you draw the two graphs, you get a point of intersection, and this point of intersection is the solution. So that gives us both width and length, and therefore we can now find area, which is 3 times 6, and that is 18 meters square. So you understand this graphical approach? Perfect. So in this approach, what are we trying to do? Let me just erase the part which is not the part of the solution from here, right? So what are we doing here is we know that the perimeter is length plus w times 2, and therefore perimeter divided by 2 is length plus width. In our case, we are given this as 18. We are going to divide 18 by 2 to write the sum of length and width, and we do get formula length plus width is 9. And we plotted this on the graph for different values of width which are taken on the horizontal x-axis. Width in this particular case is the independent variable and length is dependent on width. It is twice by from the second condition, right? Second condition was length is twice, so we'll put that in a different color, which we used here, the green color. So we get two different conditions, one being that the sum of length and width is 9, and the other being that length is twice. Plotting both the graphs on the scale, we got our result. Well, this is not very accurate. We did approximately rough diagram, but if you do it on a proper graph paper, you'll exactly get to the same values. Perfect. So that is how we could actually find this solution. So this becomes our fourth strategy. Perfect. Now I'd like you, any one of you, to summarize what we have learned. Perfect. And if there's any doubt, let's discuss it now. Okay, no doubts? Fine. So here is a question for you based on the learnings. The question is similar to what we did just now. I'd like you to write down the question and then we can discuss it. The question number one for you is find area of rectangle in terms of its perimeter P if its length is thrice the width, three times, right? If the length is thrice the width. So I'd like you to take a moment, write down what is given, what we need to figure out, and what could be the solution. Perfect. Find area of rectangle. So we need to find what area is in terms of perimeter P. So in terms of P, if length is thrice the width, we're given that length is three times the width. Perfect. So that becomes an exercise for you. I will say homework question number one. So that's a question for all of you. Let's move on and take the next example. Learn some more. Perfect. This time we are using the formulas which are known to you. Earlier in our example, we learned how do we derive a formula, correct? Now in this case, we'll use the formulas which are known to us. The example is find area and circumference of circle with radius 3 meters and r centimeters. So I've given the radius as 3 meters and r centimeters. That means there are two different circles, right? Find area and circumference of circle with radius 3 meters and r centimeters. Two different circles, correct? So there is one circle whose radius is 3 meters, the other one has general radius of r centimeters. The idea is that we have defined radius as a variable in the second case. Perfect. Part B of this question is how many times will the area of a circle increase if its radius is doubled, right? So if I have a bigger radius, which is twice the smaller radius, what happens to the area? How many times will the area increase? That is the second question. Perfect. So that is what we will do. We'll use the known formula, which are area of a circle is pi r square and the circumference is 2 pi r. With these formulas, we can make a table. Now see, since we are interested in two different circles, one with radius of 3 meters, the other with r So let's make these two circles. And for both, we will calculate area and circumference using the formula. Area being pi r square. Pi times r, which is given to us as 3 square, we get 9 pi as our answer. Well, some of you can use the value of pi as 3.14, right? So let's remember that pi is equal to approximately 3.14, and we can always use this value to get an answer. 9 pi is actually the exact answer. We'll work with 9 pi as such. Okay. As far as circumference is concerned, 2 pi r, substituting the value 3 for radius, we know it is 6 pi meters. So now we have exact value as answer to this particular question, since we knew that the radius is 3. Substituting 3 in the formula, we got our answer. The second circle, well, we have just written the formula itself since the radius is r. Okay, so the formula pi r square for radius, 2 pi r for circumference. Now, I've made here the third circle also. In the third circle, since we want to do part B now, part A is done, correct? So that is our part A. In part B, what do you think? By how much will the area increase? Will it remain same? Will it double? Or will it be 4 times or 6 times? What do you think? Okay, let's look into the formula. The radius is doubled, so instead of r, we will write 2r. So the area now becomes pi times 2r whole square. Both 2 and r are squared. Do you see that? So 2 square is 4. 2 square is 4. So we could write this as pi times 4 r square. And that gives you 4 pi r square. So now the area is not pi r square but 4 pi r square. From these two, we can relate what happens to area. Clearly, area becomes 4 times. Do you see that? The area becomes 4 times. So when you double, area is 4 times earlier. Perfect. So when radius is doubled, area becomes 4 times. So that is how, using formulae, not the values, in general also, we can see how these parameters can be related. You get an idea, right? So that is the beauty of these formulae. They help us understand the situation better. And in this particular example, you also saw how from the given formulae, which have variables in them, substituting values help us to give a perfect answer, and with variables also we get relations. Correct. So let's conclude. Area and circumference of any circle can be calculated by substituting numerical value of radius r in the formula pi r square and 2 pi r respectively. That is what we did in this particular case. Correct? Now, we also saw that the radius r, it is a symbol and it is called a variable. Correct? Which can be replaced by any valid value or even an expression. So you see, we wrote r, instead of r, we wrote 2r. We could put anything here. We could also write a, we could also write 5, a number, as we wrote 3. So this formula can help us, since we can write different values for the variable and then look into the situation. So I hope you understand this part. Perfect. Now let's take another question based on this example. This is a question for you to practice. So in this particular case, we are again working with formula, right? The question here is question number 2, part A. Find volume of cylinder for the given values of radius r and the height h. So we are given 4 parts to it. radius is given to us as 3 and height of 4. Part B or 2 is radius is doubled. Instead of 3, we have given 6 as the radius, height remaining the same. In third part, radius again remains same. However, height is 3 times. Instead of 4, it is 12. And in the fourth case, the radius is doubled, but height is half. Instead of 4, it is 2. The formulae for cylinder are also given to us. Volume, in this case, in which we are interested, is pi r square. So that becomes the formula. You can write the values in terms of pi for calculating all these results, correct? So it is an application where we will see how do we use a formula for different values of variables, correct? That is an exercise for you. Part B is compare the volume of cylinder calculated in part 2, 3 and 4 with the part 1. Explain the result. So that's very interesting. As I was saying, at times we could double the radius, we could double the height, we could make height 3 times, we could do many variations of radius and height and see how the volume increases or decreases. Right? Is it proportional or what? Correct. That is what you need to observe and then write. Part C is a question for you. Will the volume of cylinder remain same if the radius is half and the height is double? That's the question. Yes or no? Explain. So you could also use the above results to explain. You get the idea. So that becomes another question for you. Question number 2. So that is your homework. I'd like you to show your work in a way so that the solutions become absolutely clear to anybody who looks at it. Perfect. That's the whole idea. Let's move on and take some more questions based on our learning. Here is question number 3, which is also based on the same formula, the, the cylinder itself. So we'll extend this to surface area. In the last case, in question number 2, we were talking about what? We were talking about volume. And now we'll consider surface area. The surface area formula is right there, which is surface area is equal to 2 pi r h plus 2 pi r square. So that's the formula which you have to use. The question here is similar to what we had earlier. The only thing is, this time we need to find the surface area of the cylinder for the given values of variables r and h. R being 3, h being 4, and b is r equals to h. Both radius and height are equal. Radius is twice the height and height is twice the radius. So those are different conditions given to us, and you need to find the value of surface area. It's tricky. Only for the first one you can actually have a value. Do you see that? For the others, what will you get? You will get a formula or a general expression. Perfect. The formula for surface area is given to us, and I've made a table this time for you. You could list out the values of r and h and calculate surface area. So that is a good way of doing it. You could actually adopt this method for solving the previous question. You get an idea. So now we have also learned that if we are given a question to be solved, we have to adopt a strategy. How should we solve it? Making a table as shown here really helps. Perfect. Now that brings us to the second assignment on this topic. The assignment is find possible dimensions of cylinder with volume of 3140 liters, right? And the pi value taken is 3.14. So I'd like you to note this particular assignment and submit it next week. Is that clear? You need to find possible dimensions of cylinder with volume of 3140. We know the formula. Volume of a cylinder is pi r square h. Perfect. So that becomes an assignment, not very difficult. From today's learnings, this should not be very difficult. But adopt different approaches to get to your solution. That is the key. Perfect. So let's move on and see the next example. That will bring us to more learning. Okay, example 4. We are still working with variables. However, this time we are working with two variables simultaneously. Well, in earlier examples also, you were working with two variables. Length and width, both were the variables, correct? This time, the question is twisted a bit. It says, find the dimension of rectangle with numerically equal area and perimeter. Well, what does it mean? It means that we want length and width. We want to find what is length and we want to find what is width when area is equal to perimeter. That is the question. Interesting, right? We know that length and width are related, and area is length times width, and perimeter is twice length plus width. That we know. Perfect. But what we need from this information, from this given information, so this is given, this is to find, and that is given. How do we figure out what could be the length and what could be the width? Remember one thing, earlier we had two conditions. We were also given what the perimeter was, correct? This time that information is missing. So we are only given one information, and that is both area and perimeter are same. What could be the dimension? Now such question could have many solutions. So we can actually get many solutions for such questions. Can you tell me why? Because length and width can have many values, right? Because their combinations, the way it is, product and sum, we have to relate the two things, product of numbers and sum of numbers. Perfect. There could be many combinations which will give us this relation. You get the idea. So that is what we need to explore. So let's look into the strategy which we are going to adopt to solve this question. And then I will leave it open for your inquisitive minds to explore further and come up with many other solutions, right? When we say many solutions, I will give you one, you have to give me three more, okay? So that is our approach. Four ways of solving the same thing. Okay, the question here is that find dimensions of rectangle with numerically equal area and perimeter. Of course, the units cannot be same, area being in unit square and perimeter being in units. Perfect. So the first solution which I have given you is something like this. Let us first define a rectangle whose width is W, length is L. Since we know length and width as L and W, area will be the product of length and width, and perimeter is going to be twice the sum of length and width. We are given the condition both are equal, and therefore I can write product of length and width equals to twice the sum of length and width. Now from here, how do we move forward? Well, the best way is assume some value. So we'll start with assumptions. Assume. So what should we assume? Let's assume something, right? So in this case, what we did was we assumed width as equal to length, right? We say, well, there are two variables. So assume something, the result is one variable. Because we assumed the other one. So now we have one variable to work with. It is much simpler to get the solution. You got the key. So when we have many variables, the idea is somehow relate them. In the previous example, they were related for us. This time, since they are not related, we will assume. And we say, well, let length equals to width. Oh, good. Now, when I do that, in that case, I can now substitute. So when I say length is width, so instead of width, I am writing length. Right? So width is equals to L, so I wrote L, and this time we have now the equation which says L times L is twice L plus L is 2L, which is 4L. Now if you see that, what do we get? Well, clearly we have this L and that L same, and that leaves us with the solution, that is the length should be 4. Do you see that part? So length is 4 units. Both are equal, and you can verify that if length and width are both 4, what do we get? Do we get the same area and perimeter, right? So 4 times 4 is equal to 16, and twice 4 plus 4. 4 plus 4 is 8, 8 double 16. We do get the same numerical values for area and perimeter. You get the idea? Now, can you tell me how can you find other dimensions where the perimeter and area is going to be exactly same? Yes, you do have an idea. You can say, well, this time let length be twice width, correct? So that gives us many of the values. You can say length will be 3 times width. You can say length will be 4 times width. Likewise, you can get so many solutions to this particular question. You like it? Perfect. That is how we could do such questions, which seem to be very difficult. We really didn't know what the values could be, but we could assume. So the key here is assume one variable, solve for the other one. Perfect. That's a very strong technique to answer our questions. Okay. Now, can you use a graph to find a solution to such situations? I'll leave that for you to explore. Okay, so here is an idea, which is the same question, example 4. We have to work with two variables. Find dimensions of a rectangle with numerically equal area and perimeter. So we have the same rectangle here, and the condition, since we know that area is equal to perimeter, we have length into width is equal to twice sum of length and width. And we have to use this particular graph paper and graph our solution. Perfect. One side could be width, the other could be length. So on the x-axis, I will take width. On the y-axis, I'll take length, make up a scale, and then find dimensions where both are equal, length and width are equal. So this is for you to explore. We'll discuss this solution later, correct? You get an idea? You have two equations to work with, correct? You have two equations to work with. You need to draw this graph for different values of length and width. Perfect. You can take any value for length and width and then calculate their product. I should write product is area actually. So calculate area and calculate perimeter. But you need to use the graph to figure out the answer. So that is another exercise for you. Let this be your assignment. Is that clear to you? So I'm calling this as an assignment. Perfect. Now let's get back to the earlier assignment. I hope you have done this assignment. In earlier lesson, the assignment given to you was, I have 13 coins in nickels and dimes. The coins have total value of $1.10. How many of each coin do I have? Do we have the answers? Yes, we do have the answers. We can now discuss the solution of this particular question. Well, how have you done it? I think you have defined the variables for nickels and dimes, right? So you define the variables for nickels and dimes, and then you place the value of nickel, which is 5 cents, and dimes, which is 10 cents, correct? And you did it. Perfect. So looking into all these solutions, what can I say? Let me summarize the results. The hint here, which was discussed, is kind of like this. Define variables in solving the problem and explain how the number and the value of coin is connected. So the variables, let them be N for nickel and D for dimes, right? So that is how we could define these variables. Well, some of you could have done like this also. Convert the amount to cents instead of dollars. We are given the value in dollars, right? It could be written as 110 cents, correct? So that makes simpler solution instead of decimal numbers, just avoiding them, right? So in that case, we came up with this result. Let N and D be the number of nickels and dimes respectively. Value of each nickel is 5 cents and the value of dime is 10 cents, and therefore the total value of all the coins will be how much? 110 cents, right? Now that is the information given to us. I like to understand what strategies have you used. So have you used the arithmetic approach, some of you? Yes, I think. Algebraic approach? Perfect. How about the graphical approach? We didn't discuss that earlier, right? Today, we discuss the graphical approach. Now, can you say how will you solve your assignment using graphical approach? Yes, let's have some ideas now. Okay. So we're given in this particular case the condition that sum of nickel and dime is 3. So let me write down here n plus d is 3. So that will give us graph number 1. Correct. So that is the sum is 13. So you can have nickels along the x-axis, dimes along the y-axis. Correct? And when we know that the sum is 13, that is to say, if I take one nickel, then there will be 12 dimes. Correct? If I take two nickels, then that will be 11. So we have these numbers here, right? So we have these numbers, and these numbers are associated with the value of the thing, correct? So we have a scale here. Number of nickels is given here as 0 to 10, and number of dimes are on this scale, where this value here is 1, 2, 3, 4, 5. So this is 10, 11, so that becomes 12. So this point here is 1, 12. 1 being the number of nickel, 2 being the number of dime, and we get the first point. Likewise, you can plot the points, right? So that will be 2, 11. So we have different points which are being represented by the equation n plus d is equal to 13. Right. So we have this equation. Now the second one for us is the value. The value is 110 cents. So when you say the value, each nickel is 5 cents. So it will be 5 times n plus 10 times d. That is what we have, right? That is the value of each. And we want that to be 110 cents. That will be the solution, right? But the combination is for each nickel in this particular case, we have to have the value total as 110 cents. So the value is drawn by this graph, which says 110 cents. So the total is, in this particular case, the graph is in dollars, $1 and 10 cents, correct. So in this graph, actually I've used the decimal values. Let me rewrite this. equation. So what I do is for each combination of 1 and 2, so if I have 1 and 12, right? So that is nickels and dimes, we could calculate the value. So the value will be what? 1 nickel will mean 0.05 plus 12 dimes, which will mean 1.20, and that gives you a value of 1.25, right? So we have that value of 1.25, which is not equal to the answer. So this point is not equal to the answer. Do you see that? Okay. But what we did on our graph was we actually plotted the graph 1, which is sum of nickel and dimes, and then we say, well, we are only interested in 110 cents or $1.10. So we draw the second graph, which is we are saying that the value is $1.10. So that is the horizontal line. You see that this horizontal line intersects the given line at a particular point, which is right there. So that gives you the answer that to get $1.10, the combination is this. Now we know the number of nickels and dimes from the graph. You see that? So it seems that we have 4 nickels, and if we have 4 nickels, and then from the graph we have 9 dimes, and that gives you a total of 9, correct? So 9 dimes, and even the value will work out. So you can check the value for 4 nickels and 9 dimes. You get the idea. So you can also use the graph and add it to your solution of the assignment number 1. Perfect. So with this idea, I will actually like you to revise your assignment, add one more model for your solution. Clear? Now at the end, we have a project for you based on our today's learning. We have seen today 4 different ways. You could do many more also, but at least 2 or 3 is expected when you are solving a question. Now, here is a project, and the project is based on the patterns which we learn. And after learning the patterns, we also saw how do we derive formulae to answer the questions, right? And then figure out the values. Combining all this, we have a project for you. The question is, a square-based pyramid is formed with each face having a pattern of equilateral triangles as shown in the figure. Find surface area of the 4 faces of the pyramid if there are 21 triangles in the bottom row. Assume each equilateral triangle has perimeter of 3 meters. Got it? So what we have is this is one face of your pyramid. So let's say we have a square base pyramid. So let me draw here a square base pyramid, right? So we have a square base pyramid. So but each face which I am drawing with these orange lines is a triangular face. So each face here is shown, let's say this face, right, is a triangular face. Now in this triangular face, the number of, it's a bigger triangle, it's not that small. It's like a pattern which we did, right? So it's a bigger triangle in which each triangle has a perimeter of 3 meters. That means unit side, 1, 1, and 1. So that gives you a perimeter of 3 meters. Perfect. But the number of triangles are 21 in all. So that means the length of the base is 21, if you can see that. Perfect. So 21 in all at the bottom. Correct. So for this, each face will have a triangular pattern. You need to find the surface area of the 4 faces, all 4 faces, right? So we have 4 faces for which you need to find the surface area. So I hope the question is clear to you. You could also make a model to represent this particular situation, right? So what we are going to look into as our marking scheme for this is we'll see the strategy for your problem solving. How do you approach this question, right? How do you develop explicit pattern rules and relate the given information, which is we have 21 triangles in the base, right? And then how do you calculate the exact value of area? Isn't that interesting? Good. So that is where we are going to end today's lesson, in which we have learned different strategies of problem solving, and we have seen how the introduction of variables help us to look into so many different situations and find out what is unknown. I hope you all enjoyed it. So we'll end here today. See you next time with some more to explore. Thanks for your time and all the best.